Good morning, everyone. Today we are here to present about the microclimate and other abiotic factors. Next. Next. So, what is microclimate? Microclimate is the distinctive climate of a small-scale area such as a garden, park, valley, or part of a city. The weather variables in a microclimate such as temperature, rainfall, wind, or humidity may be subtly different from conditions prevailing over the area as a whole and from those that might be reasonably expected under certain types of pressure or cold cloud cover. Indeed, it is the amalgam of many slightly different local microclimates that actually makes up the microclimate for a town, city, or wood. It is these subtle differences and exceptions to the rule that make microclimate so fascinating to study, and these notes help to identify and explain the key differences which can be noticed by ground level observations. So that is a microclimate, and I pass it to the next reporter.
So, what are the types of microclimate? First is the upland regions, coastal regions, forest, and urban regions. The upland regions or upland areas are places where the land in one area is higher than in the surrounding areas. Upland microclimates tend to be colder and windier than the areas around them.
So coastal regions. The coastal climate is influenced by both the land and sea between which the coast forms a boundary. The thermal properties of water are such that the sea maintains a relatively constant day by day temperature and compared with the land. So next, forest. Forest microclimate contrasts strongly with the climate outside forest. To fully understand and better predict how forest biodiversity and functions relate to climate and climate change, microclimates need to be integrated into ecological research. For example, so ang forest, it is possible for na to call an area. So next.
Urban regions. Human activity can have a big impact on the climate of local areas. One way is to the creation of large urban areas with a high density of human created structures. With the amount of buildings, the colors and materials used, factories, and the presence of large numbers of people, the climate, the long-term weather behavior of an area, including factors such as temperature, precip- precipitation, air quality, pressure, and winds, can be affected. An abiotic factor is a non-living component in the environment. This can be either a chemical or physical presence. Abiotic factors fall into three basic categories: climatic, edaphic, and social. Climatic factors include humidity, sunlight, and factors involving the climate. Edaphic refers to soil conditions, so edaphic abiotic factors include soil and geography of the land. Social factors include how the land is being used and water resources in the area. Five common abiotic factors are atmosphere, chemicals, elements, sunlight or temperature, wind, and water.
Earth's atmosphere. The atmosphere of the Earth sustains life. Animals and other creatures breathe oxygen or filter it from water, and plants grow because of the presence of carbon dioxide. Living things combine oxygen and carbon to make carbohydrates, chemicals that provide energy and are important parts of DNA, proteins, and other organic materials. The atmosphere is made up of four layers: troposphere, stratosphere, ozonosphere, and mesosphere. Next. Next is chemical elements. Temperature of the air and water affect animals, plants, and humans in ecosystems. A rise in temperature has the potential to change the way a living thing develops because it changes the metabolic rate of the organisms. All living things, I mean organisms, have a tolerance level for temperature range. For example, a human being would die if he stood out in -50-degree temperatures for any length of time. Light exposure often affects the temperature. Areas with direct sunlight are warmer.
Wind. Often abiotic factors are affected by other factors. This is especially evident with wind. The wind speed and direction affects the temperature and humidity of an area. Very high wind speeds, often in mountainous areas, may lead to stunted plant growth and limit the types of life that can thrive the area. Wind also carries seeds and aids pollination, spreading life. This lets plant forms travel out of the contained area.